This is lesson 3.3. That's going to be proving lines parallel. So everything you learned in the last lesson, you're going to need to kind of think of it backwards. So in the last lesson, we would say if parallel lines cut by transversal, then something is true about the angles, like corresponding angles are congruent, or whatever the situation is about the angles. So we'd start with parallel lines and make a conclusion about the angles. In this lesson, we're going the other way around. In this lesson, you're going to know something about the angles and their relationships to each other, and then that will allow you to conclude the lines are parallel. So we're not starting with parallel lines this time. This time we're starting with the angles, and that will allow us to determine that the lines are parallel or not. So basically, all of the theorems from the last lesson are going to have a converse that we'll be talking about in this lesson. How do you form the converse of a statement? How do you form a converse? Sam? Right. It's like you're reading it backwards because you're switching the hypothesis and the conclusion. If a conditional statement's true, then the contrapositive is a statement that needs to be true. The converse in general doesn't have to be true if the conditional statement's true. But for all of these theorems, the converses are actually also true. Okay, so generally, converses don't have to have the same truth value as the conditional. But for these, if you have a true theorem from the parallel lines section, and now we're talking about how to get the lines parallel, the converses are going to be true. Okay, so all of those postulates and theorems, like if parallel lines are cut by a transversal, then corresponding angles are congruent. All of those will have converses that are true. Okay, so look at this picture. If angle 1 is 70 degrees and angle 2 is 80 degrees, will R be parallel to S? Daniel? Because? Good. So no, R is not parallel to S. R and S are not parallel. Because if they were, then the corresponding angles should be congruent. All right, so every theorem from the last section is going to have a corresponding theorem here that is the converse of the theorem in the last section. So you should notice that all of these will be talking about two lines cut by a transversal. Okay, it doesn't say two parallel lines. It says if you have two lines cut by a transversal and they have some relation, they form some relationship between certain angles. So for example, if two lines cut by a transversal form alternate interior angles that are, what should they be if the lines are going to be parallel? They should be, Henry, congruent. If two lines cut by a transversal form alternate interior angles that are congruent, then the lines are parallel. Then the lines are parallel. Okay, we're not starting with parallel lines, we're concluding parallel lines. If two lines cut by a transversal form consecutive interior angles that are, how should they be related? Sam? They should be supplementary. If the consecutive interior angles are supplementary, then those two lines cut by a transversal are parallel. Okay. If two lines cut by a transversal form alternate exterior angles that are, Zach, what should that be? Alternate exterior that are congruent, then the lines will be parallel. If two lines cut by a transversal form consecutive exterior angles, Madeline, how should they be related? They should be supplementary. then the lines will be parallel. Hopefully you're seeing the pattern. The conclusion is going to be then the lines are parallel, okay? Given some information about the angles, that will make the lines parallel. Okay. If two lines cut by a transversal form corresponding angles that are congruent, then the lines are parallel. So again, every theorem, postulate theorem from the last lesson has a converse in this lesson that's also true. So again, notice that in the last lesson we would say if parallel lines are cut by transversal, then something about the angles, okay? This time we're going to be saying if you know something about these angles, then that makes the lines parallel. So instead of starting with parallel, we're ending with parallel. That means that you are not going to be able to use that symbol because that means what? Oops, do not use. Lost a word there. Do not use that symbol because it means what? And that's you. That means if parallel lines are cut by a transversal. So if you don't know what the lines are parallel, then you should not be using that symbol, okay? You can abbreviate those statements a little bit, but there's not going to be a symbol that we use. We're just going to abbreviate some of the words. All right, so this is, those theorems are what you're going to be writing as justifications for angle measures that you can determine and also equations you can write with the algebra to solve for a variable. All right, so here's a diagram. It says if angle 4 is congruent to angle 8, if angle 4 is congruent to angle 8, then line B would be parallel to line C because what would be the reason? Bronson? Interior angles that are congruent to the lines of parallel. Good. And he kind of caught himself. He said if two lines cut by a transversal form alternate interior angles that are congruent, then the lines are parallel. This is how you are going to abbreviate it. It's not a ton shorter, but you can abbreviate some of those words. Okay, so it's important that you remember to say not just what kind of angles they are, but also how they're related. Okay, sometimes students sort of forget to say that, and they just say, if two lines cut by transversal form alternate interior angles, then the lines are parallel. That's not true. Okay, you need to make sure the alternate interior angles are congruent. All right, that would be the first one. So when I'm asking you to explain, that's how you're going to be explaining is by citing the theorems. If 8 and 3 are supplementary, Frankie, what will that say? If 8 and 3 are supplementary, then B is parallel to C because. Okay, if two lines cut by a transversal form consecutive interior angles that are supplementary, then the lines are parallel. If you prefer to say they form supplementary consecutive interior angles, that's fine. The English sounds a little better probably. If you say if two lines cut by a transversal form supplementary consecutive interior angles, then the lines are parallel. But sometimes I think it's easier to think about what kind of angles they are before you say how they're related. So that's why I write it in that form. But as long as you get the consecutive interior in there and you get the supplementary in there, the order of those two doesn't matter. Okay, if 5 is congruent, angle 5 is congruent to angle 1. Angle 5 is here, angle 1 is there. Peter Gruber, tell me what that should be. Stop. You're needing to tell me why they're parallel. So we don't know they're parallel. If, yes. Good. If two lines cut by a transversal form corresponding angles that are congruent, then the lines are parallel. Okay, so again, all of these will be, if this thing is true about these angles, then the lines are parallel. And again, you can write, if two lines cut by a transversal form congruent corresponding angles, then the lines are parallel, if you prefer. Okay, if I told you that angle 3 and angle 8 are congruent, which lines would be parallel? Now we have 4 different lines there, right, Allison? How do you know? Okay, so where's the transversal? Line A. So if you identify the transversal first, then that makes it a little easier to make sure that you know which lines are going to be parallel. So those are the lines in the transversal that form those two angles. So that would make L parallel to M, because if, tell me the statement, Allison. Okay. If two lines cut by a transversal form alternate exterior angles that are congruent, then the lines are parallel. Again, we're starting with the angle relationship, we're ending with the lines are parallel. Okay, take a minute and look at the next two problems. We're trying to determine from the given information if A, B, and D, E are parallel. So take a second and think about that, and then we'll talk about it together. A, B, and D, E. They're saying ray, but it could also be lines or segments or whatever. All right, Hannah, tell me what you think about the first one. Okay. Two lines cut by a transversal form consecutive interior angles that are supplementary, then the lines are parallel. Okay, I need you to fill in the blanks a little bit for me, connect the dots a little bit. So tell me what you did before you determined that, yes, they were parallel. This one, right? Okay. What is that when you add those together and get 135? What did you just use? Okay, so by the angle addition postulate, measure of angle ABD is 135. And then ray AB is parallel to ray, sorry, DE. AB is parallel to ray DE because if parallel lines are cut by transversal, then, sorry, if two lines cut by transversal form consecutive interior angles are supplementary, then the lines are parallel. I'm writing it that way because when I ask you for explanations, a lot of times I'll say, cite all the postulates and theorems that you're using. Okay? That is not the only way to do that, but I think that's the most straightforward way. Does anybody have a different way that also would work? On one. Uh-huh. Did you find that one or this one? The second one? Uh-huh. So that one is 45. And then instead of using consecutive interior angles, you're using what? You're using corresponding. So if you wanted to do it, if you just saw it a different way, I mean, obviously you try to do it the most efficient way, but if you just don't see it that way, that's fine. What is it when Madeline subtracts 180 minus 135 and gets 45? What did she use right there? There's another theorem. It's really postulate probably. So this is angle addition postulate. What is it when you go 180 minus 135 is 45? How are these two angles related? How are this angle and this angle related? And that's here. No, not this one and this one. Allison. They're linear pair. So Marin, what's the theorem you would write if I wanted you to write everything you use, you do it that way? Linear pairs are supplementary, yeah. So if you did it the way that Madeline just said, you'd have angle addition postulate, you'd have linear pair postulate, well, sorry, linear pair supplementary, and then you would have the parallel line, or sorry, the two lines, blah, 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 with corresponding angles here and congruent there. So there are more than one way, there is more than one way to do that problem or problems like that. Okay, how about this one? Caroline, what do you think? Okay, and what's the problem with that? Oops. Okay, good. So 71 and 34 is giving you 105 degrees. That would be angle addition postulate, right? But ray BA is not parallel to ray DE because the alternate exterior angles are not congruent. So just like you can write equal and not equal, you can write congruent and not congruent. If you want to write the word not, that's okay. But this is valid notation for saying not congruent. All right. So you're going to see problems on your homework that will ask you things like this, you know, angle 4 is near to angle 8, why are B and C parallel? Or find the value of X that make the lines parallel. For problems on your homework, you need to make sure you're writing the theorems. Because number one, it justifies it, and number two, the more that you write them, the more it'll stick in your brain. So it's not like you're going to have 100 problems or something, but you should be citing the theorems in the problems that you're doing on homework. Okay, so if we're doing this, we're trying to find the value of x that makes L parallel to M. Okay, it says determine the value of x that makes L parallel to M. So you want to make sure you're paying attention to that so that you know whether you're starting with parallel lines or whether you're concluding parallel lines. Okay, so they're saying we want to figure out x that makes those lines parallel. Okay, so we need what? What should our equation be? How should 5x minus 5 and 6x minus 20 be related? So I haven't talked to you today? Andrew, Joan, Riley, Pete, Liana. That might be it. Zach, I'll take you if you want to. Go ahead. Okay. We need 5x minus 5 to be equal to 6x minus 20. Tell me why. Okay, so if two lines cut by a transversal form, and again, you can say congruent alternate exterior, or you can say alternate exterior angles that are congruent. Alternate exterior angles congruent, then the lines will be parallel. Okay, so we need 5x minus 5 and 6x minus 20 to be equal. And that would give you, what, x equals 15? And if you plug that back in, that's going to give you, what, 70 degrees? It didn't actually ask you to find the measures of those angles, but clearly those should be congruent if the lines are going to be parallel. So it's always good to kind of just do a quick little mental check. All right, last problem. Pete, what do you know? Okay, we need 3x plus 10. Hold on one second. 3x plus 10 and 5x plus 18 added up to equal 180 because hold on. Do we know that they're parallel lines? We're trying to make the lines parallel, okay? It doesn't say in the problem they're parallel. It doesn't show you that they're parallel. It's asking you, what do you have to know in order to make the lines parallel? So make an equation and force those angles to have the right relationship. So you don't want to be saying if two parallel lines, okay? You want to be saying if, tell me what I should say. Two lines cut by a transversal form consecutive interior angles that are supplementary. And the lines are parallel. Okay, so we need those to add up to 180. So that's 8x plus 28 equals 180. 8x is, what is that, 152. X goes in 119, I think. You agree with those numbers? All right. So again, on any of the problems where it asks you to solve for x, or it says, you know, kind of like, really, it's almost all the problems in 3.3, even if the directions don't say it, because these are going to be book problems, even if the directions don't say it, I want you to write out the theorem that justifies your work, okay?